All right, y'all, this is the last lesson in this unit. So this is 1E in your Achieve book. And there's really nothing new here. What we're going to do this time, though, is we're going to compare our distributions. So if you remember when we talk about describing, when we describe a distribution, we use SOCS. Now we're going to compare two distributions, and we're still going to use SOCS. So nothing's really changed. So we can use comparative dot plots. That's one way to do quantitative data. We can do stem plots. And remember, this can also be called stem and leaf. We can use a histogram. And every time we do this, we can compare, we display data for one quantitative variable in multiple groups. So when you're describing the distribution, you should always discuss, and we just talked about this, so shape, outliers, and remember this also includes gaps and clusters, center, spread, and this is always in context. Super important. We have to talk about what we're really talking about. So here we go. We have an example. It says football or soccer is the most popular sport in the world. In the United Kingdom, the supporters of rival clubs can be particularly passionate about cheering for their beloved teams. One of the greatest football rivalries is between Man U and Liverpool. So here are two dot plots. The number of goals scored by each team during all of the recent matches in the season. Compare the distributions of the two teams. So compare the distributions. So what we're doing is we're looking at SOCS here. So I'm going to just start with shape. That's my first one here. And what I would say is that Liverpool is unimodal. So Liverpool is unimodal. With a peak at 2, gaps between 4 and 6 goals, and 7 to 9 goals. And then I'm going to say Man U is also unimodal. With a peak at 1 and no gaps or obvious outliers. And I'm going to add one more thing. Both teams are skewed right. So this is a comparison when I say both teams, okay? So let's go on to our outliers. So we'll say Liverpool. And you know, when I talk about a gap here, this O comes over here in shape when I talked about no gaps or obvious outliers. You don't have to list these as shape, outlier, center. If everything is in here, even though it might not be under this O, that's okay. That's so good. They don't even care about this. You don't even need to write the S or the O. So I would say here, Liverpool has a potential outlier. At 9 goals. But Man U doesn't, which I've already said that. All right, so let's talk about center. So if I talk about center here, I would say Liverpool has a median. And median's easy to look at here because I have 1, 2, 3, 4, 5, 6, which is going to put me here, and this will put me here. So I'm going to say median of 2 goals. And if I look at my median for Liverpool, so this is going to be important, which is greater than, that's a comparator word, that's what we need, greater than Man U at 1 goal. Okay, and now I'm going to talk about my spread. And with my spread on this, I'm going to say that the range is 9 goals to 5 goals. So Liverpool has a greater range at 9 goals. So which has more variability. Than the 5 goals for Man U. Okay, kind of a little bit all over the place, but I got all of the key things here when I'm doing a comparison. All right, let's flip this over. Okay, so when we're comparing distribution, so if we've got more than one thing, we did stem plots, and this is an example of a back-to-back stem plot. So this is a back-to-back stem and leaf, which is really common, where we're going to look at this middle number right here, and that's going to be our base, and then this becomes the second digit, and this becomes the second digit. So this is a little confusing. If I see this 8, 2, so here I have 8, 2, this would mean 82 beats per minute. So here it's easy, 86, but if I look on this side, it's 82. This is still always the first digit, okay? And so we can use these back-to-back stem and leaves when we're comparing quantitative data, okay? The leaves on each side are placed in order. And remember, if there's something missing, you just leave it blank over here. So if we see that this is 11 and there's no 11 point anything, it's just blank. So we would leave this just blank here. Okay. So what we're going to do is, I'm not going to go through all of these right now because I think we're going to get a lot of practice on this, but I am going to talk a little bit about what the distribution looks like. So if you look at this distribution, I'm going to just kind of draw it like this. And if I turn this, I can see that this is going to be a skew right. All right, so this is going to be skewed right. Now, if I look at this side of my graph, and I look at it like this, well, this graph looks like it's skewed left. But let's talk about what happens here. We have to look at what the numbers are. So the numbers are increasing in this order. So this value here, if we're going from this 6, this direction, then what's happening if we look at this graph is that it's still a skewed graph. And I think that's really important that you see the difference when you can turn the paper. So just because I draw it this way, this is still going to be skewed right. And so this is really tricky, and that's why I wanted to show you this. It looks like it's skewed to the left, but our numbers are increasing. So because the numbers are increasing, this is going to be skewed right. So don't get jammed up when you look at the data. You actually have to look at what the values look like so you know what this looks like. So in this case, we would say that both resting and after exercise, both of these are skewed right, that the distribution on these are both unimodal, right? But that the peaks happen in different places. So the peak here is happening in the 70s and the peak here is happening in the 90s, okay? We can talk about outliers. So with outliers, we have a potential outlier here at 14.6. We have a potential outlier here at 12, okay? So with center, when we see these stem and leaves, looking at median is super easy because we just go back and forth until we get to the middle here. We know how many data points we have, and so that can give us where our center is. And then variability, with variability, we're just looking at the range. So our range here would be 146 minus 86. And my range over here would be 120 minus 68. Okay, so same thing, just don't get jammed up on this skewed right business. So I wanted to make sure I pointed that out. Okay, now we can also compare histograms. So here are two different things with histograms. So number one, and this is super important, be sure to use the same intervals. So these are all based on 2, right? My interval word length down here is based on 2, but if one was based on 2 and one was based on 6, then we wouldn't necessarily have the same distribution. We can't compare. So that's what this says. Make sure we have the same intervals when comparing histograms so that the graphs can be drawn using the same horizontal units. Okay, we're going to use relative frequencies. So remember, those are going to be percentages or proportions. So we're going to use relative frequencies when comparing distributions of quantitative data in histograms, especially if our groups have different sizes. So in this case, a sample of 400 words from a journal article and a sample of 100 words from a magazine article. So we have two very different sample sizes. And so it's important that we look at our relative frequency. So we have this in percentages versus just our frequency, because remember, frequency is just counts. So this says compare the center and variability of the distribution. So we don't have to do all of them, okay? So the center, let's see what this says. So if I look at these two, the center of the word length distribution, this is my context. For the journal, appears slightly greater than the magazine. So if we look at this, so here's the journal, here is the magazine. So if we look at where the center is, we've got all of this data that's out here. So if I look at this, it looks like it's going to be more in here for word length versus what I have here. This huge peak is going to draw everything back. So it's probably going to be a little bit less. Okay. So if we look at variability, this goes from 14 to 2, and this goes from 14 to 1. So I would say that the variability in word length is similar. Don't say equal because we don't have any numbers. We don't know that, but the word length, the variability is similar. So 14 to 2 versus 14 to 1. And you can put values in there. It's going to ask you sometimes for the value. And so you could do, your comparison could have values in there as well. Okay? All right, let's look at this last page. So when we're looking at distributions with box plots, what's important here is that this tells us that box plots are especially effective for comparing the distribution of quantitative variables in 2 or more groups. Just remember to discuss shape, outlier, that's a U, center, and spread in context. And I know I'm beating that down, but it's super important. All right, so here's what we have. We have 2 distributions, and let's just talk about these distributions before we get into it. So we see here that we have our minimum, we have our Q1, our median, our Q3, our maximum, but it's not really our maximum. Our maximum is clear out here. So don't forget that this means I have an outlier, okay? And then here is my distribution in this case. So the other thing to keep in mind is that this is 25%, and this is 25%, and this is 25, and this is 25. And if I look down here, this is 25. This little tiny piece right here is 25, right? And then this is 25, and then this is 25. So we definitely see that our shape is a little bit different here. All right, so We also have our 5-number summary, and we have our mean and our standard deviation down here. So if we want to look at this, first thing that we're going to look at is the shape. And if we look at this with our shape, we see that this is pretty symmetric. So I would say that this is pretty symmetric because each one of these distances is approximately the same. Okay. However, we're going to come and talk about this guy here in a second. So I would say that the 1968 distribution, so MLB distribution, is roughly symmetric. If we look at this one, so this distribution, if we look at this distance and this distance, so we go from 150 to 110, and then we go from 110 to 70. So even though our median is, this little part here is a little bit less, this is also pretty symmetric. So this total distance here is pretty symmetric when we look at the length of this tail and the length of this tail. So I'm going to say it's roughly symmetric, and the 1978 season is also roughly symmetric. Okay, I go in here to my outliers. Well, we know we have an outlier here. So I would say that 1968 season has one outlier at, and we know exactly what this point is because we go down here and we look at the max. So this max point here is 185, and that's where this outlier is right here. So we have one outlier at 185, but 1978 has no outliers. Okay, we get to the center. And so because I have an outlier on here, I'm going to use median. And even though I don't have an outlier, if I'm comparing, I want to use median for both. So if we look at this, I'm just going to go right here to the medians, and I'm going to say the 1978 median of 110 home runs is greater than the 1968 median of 97. And now I'm going to talk about my spread, my variability. So if I look at this, because I'm dealing with median, I would look at IQR. So my IQR here, I'm going to plug this in my calculator. So 116.5 minus 77.5. So this IQR, oh, it's got it right here. Sorry, 39. So I'm going to say that the variability or spread, either word, of the 1968 season is greater than the 1978 season. And probably what I should say here is the 1968, the variability of the 1968 season, and I should probably say IQR equals 39, is greater than the 1978 season, where IQR equals 22. So this means we've got a larger spread on those two. Okay. Last one here, comparing relative positions. So if we're comparing relative positions with quantitative data, one of the ways we're going to do this is with percentiles. So percentiles are one way to compare relative positions. And remember, this is going to be a position at, or a position is a specific percentile. And the easiest way to do this is with standardized scores, and we call that a z-score. All right, so Let's look at this. Competitive gaming is not just a hobby, but become a real profession, and gamers can make a lot of money. So the League Championship Series, the LCS, pits teams of 5 players against each other in this League of Legends. 2 ways to measure the value of a player are the amount of damage they cause and the amount of gold that they earn. So here's what we have. We have this damage per minute and gold per minute are my 2 levels here. And we have 2 means and 2 standard deviations. So what we don't know here is which one is better. And so we're going to do this by comparing our z-scores. So we're going to convert these to standardized score. And then from the standardized score, we can actually compare. So I want to find the z-score of this damage per minute. So z-score, and this is just a little subscript of damage per minute. And if you remember, it's going to be the value minus the mean over the standard deviation. And it says here that one player had rates of 182 DPM and 228 GPM. So was Chime better at causing damage or earning gold? So we're going to see if this guy's better at which one. So for DPM, it's 182. So I have 182 minus my mean, which is 477.488, divided by my standard deviation, which is 240.194. Now, we know this is going to be a negative number, but let's see what this looks like. Oh, so I have 182, 477.488, and I'm going to divide that by 240.194. So I get a z-score here of negative 1.230. Okay, now I'm going to do the z-score for the gold per minute. And it was 228. The mean gold per minute is 365.317. And I'm going to divide this by the standard deviation. And I plug this in my calculator. And I get negative 1.652. So those are my 2 values. So now what I want to do is I want to compare this. Is he better at this one or this one? And so that's why z-scores are so incredible, because now I can compare this. So when you look at this, initially you think, oh, this is a bigger number, but this is a more negative number. So on a number line, we would have negative 1.23, which would be right here, and negative 1.65, which would be right here. So this is gold, and this is damage. And so what we see here is that he's averaging, so I'm going to say Chime, oops, I'm not really sure where that name came from. Chime is below average for both DPM and GPM. And I know this because they're both negative. So because they're both negative, he's going to be below average. So I can say because the z-score of negative 1.230 is greater than negative 1.652. And y'all, this is totally an okay way to write this. You're just using math speak to show greater than. You can type out greater than if you want to, but this is greater than. We would say, okay, so because the z-score of negative 1.23 is greater than negative 1.65, he is better at causing damage than earning gold. Okay, that's it.